All right, welcome to the addition rule day one. Today we're going to be talking about mutually exclusive events and finding the probability for those. Got to turn on my pen. There we go. So when you're doing this, two events are mutually exclusive when they cannot occur at the same time. So, for example, like you can't flip a coin and have it land on both heads and tails at the same time. You can't flip or roll a dice and have it land on multiple numbers at once. And no, don't get don't start arguing with me about it could land on its edge, Miss P. No, just stop it. All right, determine whether the events are mutually exclusive. Event A, roll a 3 on a die, and event B would roll a 4 on a die. So can A and B happen at the same time? No, there is no way for you to roll both a 3 and a 4 at the same time. So this is mutually exclusive. I'm saving time, just writing the letters, not the full word. All right, event A, randomly select a male student. Event B, randomly select a nursing major. So if we've got, a list of students at a college, it's not either male or nursing. There are male nurses, so this is not mutually exclusive. You can have a male nurse. So there we go. Example C, randomly select a blood donor with type O. And event B, randomly select a female blood donor. So these are not mutually exclusive because you can have female blood donors who have type O. Event A, randomly select a car that is a Ford, randomly select a car that is a Toyota. You don't have a Toyota? I don't know. You can't have the one car being both a Ford and a Toyota. So those are mutually exclusive. All right. So the addition rule is the rule that we use when things are mutually exclusive. So the probability that events A or B will occur, meaning probability of A or B, is given by probability of A plus the probability of B minus the probability of A and B. If events are mutually exclusive, so they cannot happen to each other, then the rule is just probability of A plus B, because this would not exist. They don't happen at the same time if they're mutually exclusive, so it's just we add the two individual probabilities. Okay? All right, we're going to use that rule to figure out some probabilities. So you select a card from a standard deck of 52 playing cards. Find the probability that the card is a 4 or an ace. Okay, remember guys, you have ace, 2, 3, 4, 5, 6, 7, 8, 9, and then you have jack, queen, king. Those are your 13 types of cards. And remember, you have hearts, and I'm just writing this now just to kind of remind you, hearts, spades, clubs, and diamonds. Oops. Okay. Hearts, spades, clubs, and diamonds. Those are your 4 suits. Okay. Now, 4 or an ace, it doesn't say anything about our suits, so we don't really need that. I just wanted to write that to kind of remind you. 4 or an ace. So ace or 4, these are mutually exclusive. You cannot have a 4 and an ace. It's not the same card. They are 2 different cards. They cannot occur together. So to find this probability, because they are mutually exclusive, all you have to do then, picking a different color. Probability of 4 or ace is just going to be the probability of a 4 plus the probability of an ace. Okay, well, there are 4 fours. I guess we did kind of need this. There are 1, 2, 3, 4. So there's a 4 of hearts, a 4 of spades, a 4 of clubs, and a 4 of diamonds out of the 52 cards. Plus, there are 4 aces, hearts, spades, clubs, diamonds. So that's out of 52 as well. So that is 8 out of 52. Oopsies, sorry. 8 out of 52. There we go. Whoopsies, I don't know why I'm adding. That equals, there we go. When I reduce that fraction, it is 2 over 13. And then if I were to find the decimal of that, it would be 0.154. Hey guys, can you do me a favor and make sure that when you're in my math lab, you are paying attention to how my math lab would like you to enter the answer? So many of you are getting your quizzes wrong because you are missing points on your homework because you are not paying attention to that. And it might say, hey, enter that in a fraction form, and you go to enter the decimal. That's like, please just pay attention to that. All right, you roll a die, find the probability of rolling a number less than 3. So numbers that are less than 3 on it, we're just going to assume it's a 6-sided die. So the numbers less than 3 are 1 and 2. Or an odd number. The numbers that are odd numbers on there, oops, sorry, picking a pen. The numbers that are odd numbers on there are 1, 3, and 5. So here's the deal. 1 shows up in both of those lists, so that is not mutually exclusive. Wow, that green does not show up very well for me. I hope it shows up better for you. So when you do this, the probability that you want a number less than 3 or odd is going to be, because it's not mutually exclusive, you have to use the first line of that equation in that little chart that we just looked at. So probability of less than 3 plus the probability of odd minus the probability that it is less than 3 and odd. Okay? So we'll just do it one fraction at a time, and it's not too bad. So when you do this, okay, probability less than 3, well, there are 2 numbers out of the 6 numbers that are less than 3, right? Plus, for probability of odd, okay, there are, and I don't know why I didn't do that well, it doesn't matter. Okay, probability of odd, there are 1, 2, 3. 3 out of our 6 numbers are odd. Okay. And then, minus the probability of 3 and odd. Well, I'm sorry, less than 3. I keep forgetting to say that. Less than 3. Sorry. 1 is both odd and less than 3. So it is, it's weird because I'm writing a 1, but it's just one number is both less than 3 and odd. So subtract 1/6. So then you simplify that. You get 2 plus 3 minus 1 is 4/6, which is 2/3, which is 0.667. Okay? All right, a card is selected from a standard deck of 52 playing cards. Find the probability that the card is a face card or a heart. So here's the thing. Face cards are Jack, Queen, and King. Okay? The problem is you have a Jack, Queen, King of spades. You have a Jack, Queen, King of hearts. You have a Jack, Queen, King of diamonds. And you have a Jack, Queen, King of clubs. Okay? So those are all your face cards. And then your hearts, right? You have an ace, 2, 3, 4, 5, 6, 7, 8, 9, and then a Jack, Queen, King. Those are your 13 hearts. Okay? And if you look, these 3 that I said were Jack, Queen, King of hearts, go with those 3 right there. They're Jack, Queen, King of hearts. So this is not mutually exclusive. I have overlap. So what I have to do when I'm finding this, the probability of a face card or a heart is going to be the probability of a face card plus the probability of a heart minus those cards that are both face cards and hearts. Okay, so probability of face cards, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12, right? 12 of the face cards out of 52. plus there are 13 hearts out of 52 cards, minus there are the 3, oops, sorry, don't know, I said 3, I was thinking 3, but I wrote 13. There are 3 out of 52 cards that are both face and hearts. Okay, so when you simplify this one, you get a 22 out of 52, which reduces or simplifies down to 11 over 26, which is a 0.423. Okay, day 1's done.